In our last lecture of kinetic theory, we already discussed about the behavior of gases and what about the ideal gases, how the gases behaves in low pressure and high temperature, likewise ideal gases. Okay, there are some specific conditions and the equations for the ideal gases like PV is equal to nRT, and one more useful form we have perfect gases PV is equal to mu RT, where mu is the number of moles. Uh, Another useful form we discussed in our last lecture is P is equal to rho RT upon m naught, where rho is the density of a mass density of a gas. Okay, and we discuss about the Boyle's law, which says that keeping the temperature constant and pressure of a given mass of a gas, that will vary inversely with the volume. And we have discussed some PV curves. Okay, now go for some more equations. So first of all, write down the topic kinetic theory. Under this we have a topic of PV curves. Now discuss the Charles law today, starting from a Charles law. At very high temperatures and low pressures, we have volume is directly proportional to the temperature. That it means it is fixed for pressure and the volume of a gas is proportional to its absolute temperature. This will be a Charles law. For a fixed pressure, volume is directly proportional to the absolute temperature. That means now if we consider a mixture of non-interacting ideal gases mu1 moles of gas 1, keeping the PV curve in our mind, if we consider a mixture of non-interacting ideal gases mu1 moles of gas, that is 1, mu2 moles of gas 2, in a vessel of a volume at temperature T and pressure P. It is then found that the equation of state of the mixture is then equation of state of mixture is PV is equal to mu1 plus mu2 plus RT. Okay, that means PV is equal to mu1 RT upon V. P is equal to mu1 RT upon V plus mu2 RT upon V plus so on. Okay, so in short we can write this P1 plus P2 plus and so on. P is equal to. Clearly what we have here, it's clear that P1 is equal to mu1 RT upon V is the pressure gas 1 is the pressure of gas 1, and if you would exert the same conditions of volume and temperature, if no other gases were present, then this is called the partial pressure of the gas. Would exert same conditions if no other gases were present. This is called the partial pressure of the gas. Now, this is the Dalton's law of partial pressures also. Dalton's law of gaseous pressures. Okay. Now come on the TV curves. That will be a temperature and volume curves. We already know about the PV curves. Okay. It's quite different from them. On x-axis I am taking volume just like PV curve, and at y-axis except of taking P, I am taking temperature here. Now calibrating the axes. So let us suppose this is at 100, this is 300, 400. Okay, here we have 0 absolute, and 2 here we have zero point 0.4, 1.0. Now how the pressure varies according to temperature and volume. These are for the ideal ones. This is for P2, this is for P3. Now what are the absolute curves? This will be a P1, this will be a P2, P3 and P3. This figure is the experimental graph with experimental TV curves. These are the solid lines for CO2 at 3 pressures compared with Charles law, that is dot in form of dotted lines. T is in units of 300 Kelvin, V in units of 0.30 meters. At 3 pressures compared with Charles law. These are shown in graph. Here T is in units of 3. V is in units of. Now go for some new topic, that is the kinetic theory of an ideal gas. Here some more new statements over here. We will discuss this topic in our new session, next session.